Okay, hello everyone. Okay, this video is the second part of your homework problem 11.60. Okay. This is going to a huge calculation problem, so I have to divide the video in three different parts. Okay, so let's look back to it. Not here. Oh yeah, let's look back to what the problem is. Yeah, this problem want to determine a maximum internal moment. Okay, if we give you the maximum allowable tensile stress and a maximum allowable compression stress for the beam. Okay, so first of all, our calculation procedure is first of all you need to find the neutral axis of the cross section. You have to do it. Okay, because this is not symmetric. If the cross section is symmetric, yeah, you can easily find a neutral axis. You don't need to do a calculation if the cross section is symmetric. But right now it's not symmetric, so you have to calculate ourselves. Okay, so the first problem is find the neutral axis. Okay, so the next step is find the moment of inertia of the cross section area. Okay, find the I. Okay, find the moment of inertia of cross section. Okay, in this problem, we have four rectangular shape. So you have to calculate the moment of inertia of each rectangular shape. You have the four shape. And the most important thing, okay, in the previous video, we already calculated the moment of we already calculated the neutral axis is here and identify the position of neutral axis. Yeah, and then you see this neutral axis is not passing through the centroid of each area. Yeah, the neutral axis is here, but this is the centroid of each area. The neutral axis is not passing through the centroid of each area. So you have to use a parallel x theorem to calculate moment of inertia of each area. So you have four areas. So yeah, it's going to be a heavy calculation. Okay, let's find the moment of inertia. Moment of inertia. Okay, the moment of inertia. Okay, maybe. And we have the zoom out. Okay. Okay, so in this problem we have four areas. We divided the shape into four areas. So the total moment of inertia is equal to I1 plus I2 and plus I3 and plus I4. So we have to calculate four moment of inertia. And we have to use the parallel x theorem because the neutral axis is not passing through the centroid of each section. Okay, so let's calculate I1 and I2 first. Actually, I1 is equal to I2. Okay, so only calculate one first, only I1 first. So I1, yeah, the pen does not respond very well again. Okay, so I1 is equal to I2. Okay, so right now that's our neutral axis is here. Neutral axis is a horizontal. So okay, right now and so it's 1/12 bh cubic. BH cubic. Okay, you remember BH cubic here. But right now it's a neutral axis horizontal one. So here is your B. 25 millimeter is your B. And sorry. And BH cubic, your H is here is 75 times 10 to the power minus 3 and cubic. And then yeah, that's not over because the neutral axis is not passing through the centroid of area 1 or area 2. So you need to use a parallel x theorem. So you need to add AD squared. A is the area of area 1 or area 2. So area for area 1 is 25 millimeter times 75 millimeter. 25 millimeter and 75 millimeter. And also d squared. What is d? D is the distance between your centroid and your neutral axis. So be careful. What is your d? What is your d? Yeah, it's a very important question. What is your d? Your d distance between centroid and neutral axis. So here is your d. here is your D. Okay, so what's the distance? Yeah, what's the distance? A very important question. So let's say the distance. So here is 37. Let's say, okay, so this part is 84.72. This part is 84.72. So if we subtract the 37.5, that will be our D. Did you get it? Yeah, here is 84.72, and we want a distance here, so we minus the distance here. So here is 37.5. Okay, so here is 84.72 minus 37.5, and we have to times the 10 to the power minus 3, and have minus 3. So this was AD squared. Don't forget it. Okay. So let me see if my calculation is right. Let me see. AD squared. AD squared. Let me see. First of all, let me check my answer. I need to check my answer. So 7 plus 5 plus 是的，yeah, it's correct. Yeah, it's correct. Okay, so it's correct. Okay, so what's the value for the I? Okay, so what's the value for the I? So what the value for the I1? So if you use your calculator correctly, so that will be, so it will 8.789 times 10 to the power minus 6. Oh, sorry, minus 7, and plus 1.875 times 10 to the power minus 3. So here is 2.230 times 10 to the power minus 3. Okay, so finally you will get the I1 is, your I1 is 5.06 times 10 to the power minus 6 in M4. Okay, that's I1 and I2. Okay, so now finish, we have to I3 and I4. Okay, so what's our I3? Okay, so what's our I3? Okay, what's our I3? I3, okay, so first term is 1 over 12 BH cubic, 1 over 12 BH cubic. Wow. So right now the neutral axis is horizontal, so your B is here. Your B is 150 plus 25 and plus 25, so it's 200. Okay, so it's 200 millimeters. It's 200 millimeters. BH cubic, H is 25 millimeters, so 25 millimeter. BH cubic, okay, BH cubic, sorry, BH cubic, sorry, cubic, okay. And because right now the neutral axis is not passing through the central area, so you need to use parallel x theorem. So you have to AD squared. What's your A? Your A is 200 millimeter times 25 millimeter. That's your A, and your D squared. And what is your D? That's very important question. What is your D? Okay, yeah, I think I need to delete this. Okay, so what is your D? Okay, what is your D? Okay, so let's zoom in this home. What is your D? D is very, very small. Your D is here. See, that's your D. That's your D here. This is your D. Okay, so what's the distance here? Is I think it's very small. So here is 25. Okay, so let's see. So here is 84.72, and here is 75. So actually this, what's the distance here? Actually this is 84.72 minus 75. So what's the value? Is maybe 9.72 millimeter. So here is 9.7. Yeah, look at this picture. Here is 84.72. So in here is 75. So this distance is 9.72. So this is a centroid. So the D must be okay. So look at so the D is 25 divided by 2. Yeah, because it's a D, so this is 25 divided by 2, and you have to minus 9.72, and times 10 to the power minus 3, and this is square. Okay, so that's your D square. That's your D. Okay, that's your D for I3. Let me see. Yeah, that's true. So okay, so you put everything together. So in there, so what will you get? You will get here. Let's see. The first term, okay, is 2.604 times 10 to the power minus 7. Okay, and the second term is 3.8642 times 10 to the power minus 8. So finally, you will get 2.99 times 10 to the power minus 7 and M4. Okay, that's your I3. Okay, so the final part, what's your I4? Yeah, it's not finished yet. It's not finished yet. Okay, what's your I4? Okay, the first term 1 over 12 BH cubic. Okay, let's go back to, I have to read. Uh, yeah, okay, BH cubic. Right now, neutral axis is the horizontal one. So your in area 4, your B is 25, H is 100. So BH cubic. So it's 25 millimeter times 100 millimeter cubic. So it's 25 millimeter and times 100 millimeter cubic, and plus AD squared, because right now the neutral axis is not passing through the centroid. So, okay, let's see. What is your D? Yeah, it's very important problem. What is your D? Oh yeah, your D is here. Right now, for area 4, right now your D is here. Your D is here. Distance between the centroid and the neutral axis. Centroid and the neutral axis. So, okay, so what is your D? Okay, um, so let's see, what is your D? That's a good question. So here is 25 minus 9.72. Okay, so, okay, here is 25 minus 9.72. Okay, what's the 25 minus 9.72? What's value? 25 minus 9.72. So it's 15.28. Okay. So, and then you have to add this distance here. Okay. So here from this edge to the central axis is 15.28. But you have to add to the distance here. So this distance here, because here is 100, it is a centroid, so here is 50. So it's 50 plus 15.28. Okay. So it's 50. So it's 50 plus 15.28. 8. This is time to 10 to the power minus 3. Okay, this is a D square. Okay, this is D square. Yeah, I forgot the A. Okay, A is, I think it's 20. What? 20 minus times the 100 millimeter. Okay, let me check. Okay, 50 plus. Yep, yeah, I got it right. So if you once again using your calculator, so your answer will be, the first term is 0.8086 times 10 to the power minus 6. Okay, so and plus 1.065 times 10 to the power minus 5. So a final answer will be 1.2733 times the 10 to the power minus 5. Okay, that's your I4, and then you add all these together. I equal to I1 plus I2 plus I3 plus I4. So what's your answer? So okay, just give you the answer. So I1, I2 is the same. So plus I3 plus I4. Yeah, this not response very well for this pen. Okay, so anyway, so it will be 2.3152 times 10 to the power minus 4 and m to the power 4. Okay, that's the moment of inertia of this cross-section area. So it's a long calculation because you have four area. You have all four area, and more steadily is the neutral axis is not passing through the centroid of each area. So every moment of inertia, you need to use the parallel axis theory. And for the parallel axis theory, the most important thing, what's your distance between your centroid and the neutral axis? You have to find it by yourself. So you have to be very careful. Okay, so I think this is the second part of this problem. So we haven't finished yet. We haven't finished answering problem. We just calculate the neutral axis and moment of inertia. That's all. We haven't answered the question. And I'll answer the final answer in the next video. So see you in the next video. Okay, bye bye. Mhm.